Today we begin with Module 1, which focuses on the Introduction to Data Analytics in Decision Making. This title establishes the central theme of the course, which is the connection between data and organizational decisions. At its core, this module is about understanding how data becomes a foundation for making informed choices in modern environments. When we refer to data analytics, we are not simply referring to numbers or data sets. We are referring to a structured process that allows organizations to examine information, extract meaning, and use that meaning to guide action. Decision making in this context is not random or purely intuitive. It is a deliberate process that involves evaluating alternatives, considering uncertainty, and selecting a course of action based on available information. Organizations make decisions continuously. They decide how to allocate resources, how to respond to changes in the environment, how to improve performance, and how to achieve long-term goals. These decisions can be strategic, meaning they focus on long-term direction, or operational, meaning they focus on day-to-day activities. In both cases, the quality of the decision depends on the quality of the information used to support it. This is where data analytics becomes essential. It provides a systematic way to transform raw information into insights that can inform decisions. Instead of relying solely on intuition or past experience, decision makers can use data to better understand conditions, identify patterns, and evaluate possible outcomes. This does not eliminate uncertainty, but it reduces it by providing a clearer picture of what is happening and what may happen next. The relationship between data and decision making is central to everything we will discuss in this module. Data analytics serves as the bridge between information and action. Without analysis, data remains unused. Without decisions, analysis has no impact. The value comes from the connection between the two. As we move forward, it is important to understand that data analytics is not a purely technical activity. It requires interpretation, judgment, and context. The same data can lead to different conclusions depending on how it is analyzed and understood. This means that decision makers must not only rely on data, but also think critically about what the data represents and how it should be used. This module will introduce the key ideas that define how analytics supports decision making. We will explore how data is transformed into information, how that information is used to reduce uncertainty, and how organizations apply these insights to improve outcomes. The goal is not only to understand analytics as a concept, but to understand its role in real decision environments. Ultimately, data analytics is valuable because it connects information to action. It helps organizations move from observation to understanding, and from understanding to decision. This connection is what allows organizations to operate more effectively in complex environments and make decisions that are more informed, more consistent, and more aligned with their objectives. As we begin this module, keep in mind that every concept we discuss will build on this central idea. Data analytics is not just about data. It is about using data to make better decisions. Now, let us develop a precise understanding of the role of data analytics in organizational decision making. Data analytics is the process of collecting, processing, and analyzing data to generate insights that support decisions. Analytics is not one single action. It is a sequence of connected steps that begins with data and ends with a decision. The value of analytics is created through the movement from raw information to informed action. The first part is collecting data. Organizations constantly produce data through sales, operation, customer interactions, financial transactions, digital systems, and internal processes. But collecting data is not the same as collecting useful data for analytics to support decision making. The data must be relevant to the decision being made. If the organization collects information that does not address the decision problem, the analysis may be technically correct but practically weak. If important information is missing, the final conclusion may be incomplete. The second part is processing data. Raw data is rarely ready for immediate use. It may contain missing values, repeated entries, inconsistent formats, or inaccurate records. Processing prepares the data so that it can be analyzed responsibly. This is where the organization turns scattered information into something structured enough to examine. Poor data quality can create misleading results and lead decision makers toward poor actions. The third part is analyzing data. Analysis is where the organization begins to identify patterns, trends, and relationships. A pattern shows repeated behavior. A trend shows movement over time. A relationship shows how one factor may be connected to another. These elements allow decision makers to move beyond isolated facts and form a clearer understanding of what is happening inside the organization or environment. This is why the slide emphasized that data analytics transforms raw data into meaningful information. Raw data alone does not improve performance. A spreadsheet, database, or dashboard has no value unless the information is interpreted in a way that supports action. Meaningful information helps decision makers understand a situation more clearly, evaluate alternatives, and decide what should be done next. Data analytics also enables evidence-based decision making. In many organizations, decisions can be influenced by habit, personal preference, intuition, or assumptions. Experience is valuable, but experience alone can also be biased. Analytics reduces reliance on intuition by providing empirical evidence. It gives decision makers a consistent basis for evaluating problems and choosing among alternatives. Human judgment is strengthened by evidence. Analytics is especially important because organizations operate in complex, data-rich environments. Modern organizations are surrounded by large amounts of information. Without analytics, that information can become overwhelming. Data analytics helps organize complexity. It allows decision makers to focus on information that matters most and separate meaningful signals from irrelevant noise. Another major role of analytics is reducing uncertainty. Decision making always involves uncertainty because leaders rarely know every possible outcome in advance. Analytics does not eliminate uncertainty. Instead, it reduces uncertainty by allowing decision makers to evaluate possible outcomes more carefully. When alternatives can be compared using evidence, the decision becomes more informed, even if the future remains uncertain. This slide also reminds us that data analytics is used across organizational functions. In marketing, analytics can support decisions about customers and market behavior. In operations, analytics can support efficiency, process improvement, and resource use. In finance, analytics can support performance analysis, forecasting, and risk evaluation. This broad use shows that analytics is not limited to one department. It is a general organizational capability that supports strategic and operational decisions. The final point on the slide is just as important as the benefits. Data analytics requires critical interpretation. Data does not speak for itself. A number can be accurate and still be misunderstood. A model can be useful and still depend on assumptions. A conclusion can appear convincing and still be weakened by poor data quality. Decision makers must ask whether the data is complete, whether the assumptions are reasonable, and whether the conclusion fits context. So the role of data analytics is not simply to produce numbers. Its role is to convert data into meaningful insight, support evidence-based reasoning, reduce uncertainty, identify patterns and relationships, and guide action. Analytics must always be paired with critical thinking. When data, analysis, interpretation, and judgment work together, organizations are better positioned to make informed, consistent, and effective decisions. In this slide, we examine the three fundamental types of data analytics: descriptive, predictive, and prescriptive analytics. These categories provide a structured way to understand how organizations use data at different levels of decision making. Each type serves a distinct purpose, and together they form a progression from understanding the past to guiding future actions. We begin with descriptive analytics. Descriptive analytics focuses on summarizing historical data to explain what has already happened. This is the most basic and most commonly used form of analytics. Organizations rely on descriptive analytics to produce reports, dashboards, and visualizations that present past performance in a clear and organized way. These outputs allow decision makers to observe patterns, track results, and identify changes over time. However, descriptive analytics does not explain why those outcomes occurred. It provides visibility, but not causation. The next level is predictive analytics. Predictive analytics uses historical data to forecast future outcomes and estimate probabilities. Instead of focusing only on what has happened, it attempts to anticipate what is likely to happen next. This is done by identifying patterns in past data and applying statistical or computational models to project those patterns forward. Predictive analytics introduces the concept of uncertainty because all predictions are based on probabilities rather than certainties. Even with strong models, the future cannot be known with complete accuracy. The third level is prescriptive analytics. Prescriptive analytics goes beyond description and prediction by recommending actions. It combines data, models, and decision frameworks to suggest what should be done in a given situation. This type of analytics is directly connected to decision making because it evaluates possible actions and identifies those that are expected to produce the best outcomes. However, these recommendations depend on the quality of the data and the validity of the models used. If the underlying assumptions are flawed, the recommendations may also be flawed. These three types of analytics build on one another. Descriptive analytics provides the foundation by helping organizations understand the past. Predictive analytics builds on that foundation by estimating what might happen in the future. Prescriptive analytics builds further by using those predictions to guide decisions. This progression reflects increasing analytical complexity and increasing value for decision making. It is also important to recognize the limitations of each type. Descriptive analytics does not establish causality. Predictive analytics involves uncertainty and potential error. Prescriptive analytics depends heavily on model accuracy and assumptions. These limitations highlight the importance of critical thinking when using analytics to support decisions. In practice, organizations often use all three types together. They begin by understanding a past performance, then use that understanding to anticipate future outcomes, and finally use those insights to guide decisions. This integrated approach allows organizations to move from observation to action in a structured and informed way. Ultimately, this slide establishes a framework for thinking about data analytics. It shows that analytics is not a single activity, but a layered process that evolves from describing data to predicting outcomes and recommending actions. Understanding this progression is essential for understanding how data supports decision making in organizations. In this slide, we examine how organizations use data analytics to support both strategic and operational decisions. This distinction is important because not all decisions are made at the same level or with the same time horizon. Some decisions focus on long-term direction, while others focus on day-to-day execution. Data analytics plays a role in both. We begin with strategic decisions. Strategic decisions are long-term in nature. They involve choices about growth, expansion, investment, and overall direction. These decisions typically have significant consequences and often involve a high level of uncertainty. Because of this, organizations use data analytics to evaluate trends, assess risks, and identify future opportunities. For example, analyzing long-term patterns can help leaders understand where the organization is heading and what changes may be necessary to remain competitive. Strategic analytics focuses on broad patterns rather than immediate details. In contrast, operational decisions focus on day-to-day activities. These include decisions related to inventory management, supply chain operations, scheduling, and system performance. Operational decisions are more immediate and often require timely responses. Data analytics supports these decisions by providing real-time or near real-time information. This allows organizations to react quickly to changing conditions and maintain efficiency in their processes. While strategic decisions look ahead over a longer period, operational decisions focus on maintaining performance in the present. Data analytics supports both types of decisions by helping organizations evaluate alternatives. When multiple options are available, analytics provides a way to compare those options based on data rather than guesswork. This allows decision makers to consider potential outcomes more carefully and select the most appropriate course of action. Another key function of analytics is assessing probabilities under conditions of uncertainty. Decision makers rarely have complete information. Instead, they must make choices based on incomplete knowledge and possible outcomes. Data analytics provides tools to estimate the likelihood of different scenarios, which helps decision makers understand the risk associated with each option. This does not eliminate uncertainty, but it makes it more manageable. The slide also emphasizes the role of key performance indicators, or KPIs. KPIs are measurable values that organizations use to track performance over time. Data analytics enables organizations to monitor these indicators continuously, allowing them to evaluate whether they are meeting their objectives. By tracking KPIs, organizations can identify areas of strength and areas that require improvement. This leads to another important concept, which is the feedback loop for continuous improvement. Data analytics allows organizations to measure outcomes, learn from results, and adjust their actions accordingly. This creates a cycle where decisions are informed by data, outcomes are evaluated, and future decisions are refined based on what has been learned. This ongoing process helps organizations improve performance over time. Finally, the slide highlights the importance of combining analytical insights with contextual understanding. Data alone is not sufficient. Decision makers must interpret the results within the context of the organization's environment, goals, and constraints. Without context, even accurate analysis can lead to poor decisions. Context provides meaning to the data and ensures that insights are applied appropriately. In summary, this slide shows that data analytics supports both strategic and operational decisions by helping organizations evaluate alternatives, assess uncertainty, track performance through KPIs, and create feedback loops for continuous improvement, while emphasizing the need to interpret data within the appropriate context. In this slide, we evaluate the benefits and limitations of data-driven decision-making approaches. Understanding both sides is essential because while data analytics offers significant advantages, it also introduces risks if it is misunderstood or misapplied. Effective decision-making requires recognizing not only what data can do, but also what it cannot do. We begin with the benefits. One of the most important benefits of data-driven decision-making is that it improves decision quality through empirical evidence. instead of relying solely on intuition or personal judgment. Decision makers can use data to support their conclusions. This leads to more informed and more consistent decisions. When decisions are grounded in evidence, they are less likely to be influenced by individual bias or incomplete information. Another benefit is the reduction of bias. Human decision making is naturally affected by cognitive biases, assumptions, and personal preferences. Data analytics provides a structured way to evaluate information objectively. By focusing on measurable evidence, organizations can reduce the influence of subjective factors and create more consistent decision processes across different situations and individuals. Data-driven approaches also enhance efficiency. Analytics allows organizations to optimize processes and allocate resources more effectively. By analyzing performance data, organizations can identify inefficiencies, eliminate waste, and improve overall productivity. This leads to better use of time, money, and other resources. Another key benefit is support for risk management. Data analytics helps organizations identify trends and anticipate potential issues before they become significant problems. By detecting patterns early, decision makers can take proactive steps to reduce risk and respond more effectively to uncertainty. This ability to anticipate and prepare is critical in complex environments. However, these benefits must be balanced with an understanding of the limitations. One major limitation is data quality. If the data is incomplete, biased, or inaccurate, the conclusions drawn from it will also be flawed. Data-driven decision-making is only as reliable as the data on which it is based. Poor data quality can lead to incorrect conclusions and poor decisions. Another limitation is that analytical models rely on assumptions. Models are simplifications of reality, and they cannot capture every detail of complex environments. If the assumptions underlying a model do not reflect real-world conditions, the results may be misleading. This means that decision makers must understand the assumptions behind the analysis and evaluate whether they are appropriate. There is also a risk of over-reliance on data. While data provides valuable insights, it does not capture every aspect of a situation. Qualitative factors such as organizational culture, human behavior, and external conditions may not be fully represented in the data. Ignoring these factors can lead to incomplete or unbalanced decisions. This leads to an important requirement for effective decision making. Data must be combined with critical thinking and proper interpretation. Decision makers must evaluate the quality of the data, question the assumptions of the analysis, and consider the broader context in which decisions are made. Data provides guidance, but it does not replace judgment. Finally, effective decision making requires balancing data insights with human understanding. Data can highlight patterns and suggest actions, but human decision makers must interpret those insights and determine how they should be applied. This balance ensures that decisions are both informed by evidence and grounded in context. In summary, data-driven decision-making improves quality, reduces bias, enhances efficiency, and supports risk management. But it also depends on data quality, model assumptions, and careful interpretation, requiring a balance between analytical insights and human judgment.